through tables. The first thing that we're going to always do, because we don't know what function it is. Okay, yes, maybe the questions can kind of hint at it, but we want to make sure that we're deciding what the function is by working through the rate of change. So that's always our starting place. What is the change in y and the change in x's? Now, don't be lazy with this. Remember our habits with the tables. We'll draw the arrows for what we're doing as we go down. And we're going to always write the sign and by how much we're adding or subtracting. -7 to -4, I add 3. -4 to -1, add 3. -1 to 2, add 3. And 2 to 5, add 3. Then for my change in y's, 0 to 2 is adding 2. 2 to 4 is adding 2. 4 to 6, adding 2. And 6 to 8, adding 2. So after we find the rate of change, this is where we pause and ask ourselves, is this constant or not? Okay, what do we think? Is this the same change in y, change in x every time? Yeah. Okay, because it's always the exact same and always the same sign, this is constant, telling us that this is a linear table. So even though we don't have questions to answer that about, these are the things we should be thinking about before we start to write the equation. So now, to write the equation, we need the slope. Slope is still change in y divided by change in x. Well, we know what that is every time, right? Change in y is 2, change in x is 3, so it's positive 2/3. Then for our points, it doesn't matter what point we choose. Okay, when it's linear, we can pick any of the 5 points listed in this table. One thing that I'll do for a linear table, just to keep it consistent, is I'll just always use the top point. Okay, but again, no particular reason, just so I'm always kind of doing the work the same way here. So the point I'm going to use is -7, 0. Okay, so now we need to write the equation. If you forget what the linear equations look like, we have examples on the front. So you can go to the linear, look at the point slope form. You also have these equations on a lot of your note sheets. Okay, so I think on the 210, when we are writing equations of graphs, you have all the different equations at that front or on the front of that note page. Okay, so really good thing to refer back to if you forget, what should your equation look like? Well, luckily, almost all equations are written very similarly, where it starts with y equals, followed by the slope. Okay, we would start that way, whether it was linear, absolute value, or quadratic. Then we have to decide the, the parentheses. We're going to use regular parentheses here, with it being linear, followed by the x, followed by the x coordinate of the point that we choose, which is the -7. We need to remember that the x coordinate is always the opposite sign from what we see. Okay, so it is x plus 7 in the equation. Then that y coordinate of plus 0, we don't need to do anything with that. Adding 0 doesn't change anything here. So we can be done right there and leave the equation as is. But if you want the y coordinate to show up in the equation, you can write plus 0 at the very end. Okay, question? Okay, you're good. All right, so right now, I want you all to try number 2. Again, prove that it is linear first, and then we'll work on to the next function from there. Okay, again, I'll ask that we try right now. Take about 2. All right, again, your starting point. Shh. It's always the exact same. Let me get eyes, ears up here, please. Find your change in y's and change in x's. Shh. Any combination of taking a change in y divided by its corresponding change in x is a rate of change. So again, we want to ask ourselves, is this constant or not? Well, if it's always the same on the change in y's and change in x's, It's pretty clear that this is constant. So that tells us, once again, that this is linear. Our slope, or the change in y divided by change in x, is 1 divided by 5. And again, we want to pay attention to those signs. Okay, since they're all plus and all positive, our slope is going to be positive as well. Then when it's linear, you can choose any point. It does not matter which one we select. I'm just going to pick the one on top just to make it consistent with how I do the linears. So that's -8, -6. So now, piecing this together in our equation, we got y equals 1/5, followed by parenthesis x, right? That's the same for almost every function that we write. And instead of a -8, it's a +8 in the equation. And then the y coordinate of -6, since we're placing that at the end of the equation, the sign does not switch. We leave it as a -6 there. All right. Any questions here before I move on to the next type of function? Okay. Well, again, we're going to treat the next table as if we have no idea what function it is. Okay, yes, we've done linear, but we're going to pretend that we have no idea, and so we need to identify that. So we start off the same way. Change in y's, change in x's. All the change in x's I'm showing are all +1. I'm okay with us just doing this and saying +1. But make sure, be careful with that, because sometimes I can be sneaky with how these are structured. Now the y's, they're not all the same, or at least they don't look to be that way. So 8 to 5, that's -3. Really important that we're getting the correct sign with the correct amount here. 5 to 4, that's -1. Then 4 back to 5, that's adding 1. 5 to 8, that's adding 3. 8 to 13, that's adding 5. 13 to 20, that's adding 7. And 20 to 9, that's adding 9. So what I'm noticing is that I'm switching from subtracting to adding. That's a huge hint for what type of function this is. That has already ruled out it being linear. Okay, linear will never have both adding and subtracting. Okay, so then we ask ourselves the same question we did before. Is this constant or not? Okay, well, every change in y divided by its corresponding change in x gives us a different number every single time. So this is not constant. Okay, and the not constant automatically tells us that this is quadratic. So now, with it being quadratic, we have to be much more intentional with what we're identifying the a to be and the vertex to be. And if you remember back to our first conversation with this, and I had you all reread the notes and then ask good questions, one question that kept showing up is, how do we find the a value? Okay, so here's, after we've identified it to be quadratic, we then have to identify the vertex. Really important that we're doing that. Okay, so the vertex, where do I switch from subtracting to adding? Okay, somewhere in here where x is -2, -1, or 0. Well, the other thing I'm paying attention to is, where do I see the symmetry, or where the y values show up more than once? Well, I'm seeing a 5 that shows up twice. So in between the 5 is that -1, 4. So that's our vertex. Again, I switch from subtracting to adding there, and I can see that I have this symmetry, okay, of these 5s to show up, and then the 8s to show up, 2 above and 2 below that. So you have a couple indicators for how to identify the vertex. So it's at -1, 4. So if you remember how we were to graph a quadratic, we'd plot the vertex, and the next set of points is how we use the a value. So when I'm looking at, okay, how would I go from my next set of points and what's the rise over run, I'm thinking, how do I go from 4 to get up to 5? Okay, I'm thinking about the amount. I'm also thinking if I'm going up or down. Well, to go from 4 to 5, I'm going up by an amount of 1. So the a value here is 1. Now, again, this was the part that a lot of you left the conversation we had the first time being like, how in the heck did he get that A value? Well, here's what we can do. You can make a quick sketch. Excuse me. Sorry to anyone watching the video having to hear me sneeze. I did not get to pause it quick enough. Anyway, another way that we could do this. Let's plot the vertex. We can make a quick set of axes. We can make a quick sketch for where that vertex is. So -1 and 1, 2, 3, 4. And then we can plot the 2 points that are to the left and to the right. So when we go left 1 and right 1, well, when I go left 1 to -2, that y coordinate is 5. So -2, 5. Okay, and when I go right 1 to -1, I'm going up, or excuse me, to 0. I'm going up to 5. Okay, so there's my vertex, and my rise over run is 1/1. Okay, so again, helping me identify that the A value is a +1. That'll be by far the hardest thing that we have to think about here. Okay, now piecing this all together in our equation. Every equation starts the exact same. Y equals, followed by the A value or our slope. You do not need to write the 1 there. That can be an invisible 1 if you choose it to be. Followed by the parenthesis. Followed by the x, right? That's the exact same as linear. Then, since our coordinate is -1, it'll be +1 in the equation. So even up to this point, exact same as linear. And now, to make it quadratic, we need the exponent to be 2. And then a +4 at the very end. Okay. Okay, so everyone in here can find the change in y's and change in x's, and thus the rate of change. Then, identifying the vertex, again, it's going to take some practice. It's not always going to be the most obvious. So again, there's 2 things that help me find the vertex. One is where I switch from adding to subtracting. The other one, I'm paying attention to the symmetry. So I see the 4s. I see the -2s. Okay, and then I also see the -12s. Okay, so paying attention to where we have those repeated y values and kind of mirroring them until we get to the middle is a good way to find that vertex. Now, the vertex is really important because that's how we're going to identify what the A value is. So the A value is what we do from that vertex. So how am I going from 6 and then to 4? Again, you can always plot the points. So I can go to 2, 6, and plot the other points that are 1 above and 1 below that vertex. So I have 1, 4, and 3, 4. And so I'm seeing that my rise over run here is to go down 2 and over 1. So this helps me identify that the A value in this case is -2. The vertex is at 2, 6. And now we need to piece this all together in our equation. Okay, so the equation, y equals -2, x minus 2 squared, and plus 6. Okay. Again, we will have to think about the exact same things when we do the absolute value tables. And I have a second note sheet for that. Is start the same way that we have with every single table. And that's to find the change in y's and change in x. And think about that rate of change and whether or not it is constant or non-constant. So all the x's, -2, -1, 0, 1, 2, 3, 4, 5, those are all +1. Then the change in y's. Be very intentional here. Make sure you're drawing your arrows for what you do as you go down. So from 4 to 7, I add 3. 7 to 10, add 3. 10 to 13, add 3. 13 to 16, add 3. 16 to 19, add 3. 19 to 22, add 3. And 22 to 25, add 3. Okay, so what kind of function is this? Yeah. Okay. I think I meant for it to be absolute value, but that's okay. Okay, so again, we ask ourselves, is it constant or not? Clearly, this is constant because it's always a +3 and a +1 on the x's. Since it is constant with no plus or minus, that tells us that this is also linear. So this is all wrong. This should be m, or our slope. Change in y divided by change in x is 3 divided by 1. And since this is linear, we can choose any point that we want. I'm just going to use the top point at -2, 4. And that's what needs to show up in our equation. Okay, so the equation is y equals 3, parentheses x plus 2, and plus 4. Okay, again, that was kind of sneaky because this is still linear. So let's do the next one together as well. And we're almost done here. You keep your attention, please. We'll get to some work time. We're going to have lots of work time today. Okay, number 6. Again, we'll pretend that we have no idea what function it is. So we start the same way. Change in y's, change in x's, or the rates of change. For my x's, I see I'm going up 2. It looks like they're all +2. My change in y's. Hey, I noticed that I go from 8 to 7, so that's -1. 7 to 6, -1 as well. Then 6 back to 7, so +1. 7 to 8, +1. 8 to 9, +1. And 9 to 10, +1. So when making the decision about it being constant or not, okay, it is constant, but with the plus or minus. Okay, so this one's kind of sneaky here. So the answering of whether or not it's constant, actually saying constant or not is kind of both correct. Okay, we're going to say that it's constant, but it has the plus or minus. That's how we know that this is absolute value. Okay, so now the vertex. Okay, so now our rate of change. We know for sure that if we take change in y divided by change in x, that it is 1 divided by 2. But what we don't know is whether or not it is a positive 1 divided by 2 or a negative 1 divided by 2. We're going to make that decision the exact same way that we do for the quadratic. Okay, so now we've got to identify the vertex. Well, where do we switch from subtracting to adding? Right here, where the y is 6 and the x is 4. So now, how we decide the sign of this a value? It depends on how we go from the vertex to those next set of points, specifically what's going on with the y's. Well, for me to go from 6 and then up to 7, we are adding 1 here. Okay, so that tells me that this should be a positive 1 divided by 2. Again, if that doesn't make sense to you, then do a quick sketch where I can go ahead and plot 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. And then I can get to 7, so 2, 7. And then also 1, 2, 3, 4, 5, 6, and 7 as well. So if I connect these, I can see that my graph opens up, telling us that the a should be positive. So you can always just make a sketch from the points provided to help you with that a value. Okay, and even with the vertex, that's a really good way of kind of using the things we've covered here. All right, so now we've got to piece together the equation. Exact same thing of how we've pieced together every equation. We start with y equals, followed by the a value, which is 1/2. This time we need the absolute value brackets, so it needs to be the straight lines and not parentheses, and then x minus 4, followed by the plus 6. So x coordinate has the opposite sign, y coordinate has the same sign. Yeah. Where I'm going to provide 2 points, And our task is going to be to write an equation of a line that passes through those 2 points. Okay, so if it's just the 2 points, these are linear. And it should say that in the equation, okay, or in the direction. So let's see if we can apply these same ideas and write the equation of a line. Okay, if it's a line, that implies the linear if we are only given 2 points. This really is the exact same problem as the linear tables. Here's why. I've got 2 points here. We have already been told that it's linear, so we need to find the slope and a point. Well, we're given 2 points, so we really just need to find the slope. Well, let's go ahead and place those 2 points in a table. Okay, so negative 3, 7, that's an x and a y. Negative 5, 10, that's an x and a y. So I can put that right below it. And now I can find the slope by finding the corresponding change in y and change in x, just like what we did with the linear tables. So 7 to 10, I add 3. Negative 3 to negative 5, I subtract 2. That's not for us. So now we have our change in y divided by change in x, and we have a point. Okay, so not really any different, except that we just have to put the 2 points in a table to start. So our slope here is negative 3/2. The point, I like choosing the top point, so negative 3, 7. And now piecing this all together, y equals negative 3/2, x plus 3, and plus 7. Okay, let's do one more. And then you all will do 9, and we'll be done from there. 9's kind of a trick. Actually, let's do 9. I want you all to do 8. 9's kind of a trick because when I take these 2 points and I plot them in the table, I have negative 1, negative 9, and 5, negative 9. When I go to find the change in y's and change in x's, negative 9 to negative 9, that's a plus 0. The change in x, negative 1 to 5, that's a plus 6. So our slope here, change in y divided by change in x, is 0 divided by 6. That's a slope of 0. And this is why this one's kind of odd, because the slope of 0 is one of our special lines. Okay, it doesn't have the same slope as all the other ones. So we have to remember what kind of line has a slope of 0. Well, maybe we don't remember, or we're like, we know it's either horizontal or vertical. Well, again, we can plot the points and sketch these. Okay, negative 1 and then negative 9. It's right there. And then 5. Negative 9 is right there. So when I connect these, I'm like, oh, that's that horizontal line where the slope is 0. And the only thing that we care about from the point that we choose is what stays constant. It's the y that's staying constant. So this equation is y equals negative 9. Hey, that is a lot sneakier than all the others because it's that special case. No, that's still fine, because if you were to simplify that, it still ends up being the negative 9. Okay, so this is going to be the best way to write it, but if you're still using the slope of 0 and then including the point, it's all good. Okay, if it was flipped and undefined, we can't write undefined in an equation though. So it wouldn't work if it was x equals. Okay. All right, last thing I'm going to ask you to do as part of these notes is try number 8. Then we'll start homework time after that. The remaining class time will be your time to work on that homework. All right, for the last problem here. Okay, write an equation of a line that passes through the points negative 1, negative 1, and 5, negative 9. Again, you can put them in your table, and honestly, it doesn't matter which point goes on top and which one goes on bottom. You'll get the same answer no matter what, or at least the correct answer here. Okay, so from negative 1 to negative 9, I'm minus 8. From negative 1 to 5, I add 6. Change in y divided by change in x is negative 8/6. Then the point, doesn't matter if you pick the same one as me or if you choose 5, negative 9. Just if you use the other point, the equation is going to be slightly different. So y equals negative 8/6, x plus 1, and a -1. All right.